Hey there, and welcome to the Deep Dive. Really glad you could join us today.
Hello. Yes, great to be here.
We're cutting through the noise today to get straight to the important insights on something that maybe quietly, but absolutely fundamentally reshaped our world. We're talking about the second generation of mobile networks, 2G.
Exactly. And while we're all wrapped up in 5G now, maybe even thinking about what's next, understanding 2G is it's essential. It really is the bedrock. So much of our modern mobile life was built right on top of it.
Absolutely. And this deep dive is based on some really great source material you've shared with us. It takes us right through that pivotal jump, from 1G to 2G, the actual tech that powered it all, and honestly, it's surprisingly long-lasting impact.
Yeah, that's our goal today. We want to be your guides through this material, help you pull out the really crucial bits of knowledge. We're going to unpack how 2G wasn't just like better phone calls. It cracked open the door to mobile data and, maybe just as importantly, turned mobile communication into something for everyone, a mass market thing.
Right. So we structured our chat today to really explore the core changes that happened in the 2G era. We're going to look at that fundamental switch, the big one, analog to digital, and why that mattered so much. Then we'll get into the weeds a bit with the key technologies that really define 2G, things like GSM, SMS, GPRS, EDGE. You'll know these names.
The building blocks.
Exactly. We'll also talk about how it made mobile phones accessible to, way more people, and brought us some true iconic devices. Remember those?
Oh, definitely. Indestructible things, some of them.
Totally. And crucially, we'll explore those first tentative steps, and they were slow steps into the world of mobile data and what that actually unleashed.
And then finally, we'll sort of tie it all together, look at 2G's incredible legacy and how it really shaped everything that came after it right up to today.
Sounds like a plan. So let's jump right in and explore this really fascinating moment in tech history together.
Let's do it.
Okay, let's kick off with that foundational change then. What exactly was the major leap when we went from 1G analog networks to 2G digital networks? Why was that specific shift seen as such a revolution?
Right. So the material you provided really makes it incredibly clear. The core change was moving from analog to digital. And this wasn't just, a small step up, like a minor improvement. It's described in the sources as a fundamental revolution.
A revolution, okay.
Yeah. Think about it like moving from the continuous wave of an old FM radio broadcast, or the analogy used in the source is like vinyl records, that continuous groove, right? Moving from that to the discrete ones and zeros of a CD or a digital audio file, it's a totally different way of representing the information. With 1G, your voice was basically transmitted as this continuous fluctuating radio wave, similar to how radio works.
Okay.
With 2G, that audio, your voice, was first converted into a stream of binary data, just ones and zeros, pure digital information, before it was actually sent over the airwaves.
Okay, so digitize first, then transmit.
Exactly. And this radical digital conversion, it wasn't just change for change's sake. It was a direct response to the really big problems that 1G had. Things like poor security. Anyone with a scanner could potentially listen in.
Right, I remember hearing about that.
Yeah, it was a real issue. Also, inefficient use of the radio spectrum, which is a finite resource and often pretty low call quality, of lots of static drop calls, that kind of thing. So this shift, this leap from analog to digital, it just unleashed this whole wave of benefits that completely reshaped mobile communications.
That transition sounds like the real crux of it then. You said it unleashed a cascade of benefits. Can you break down some of those specific, maybe immediate improvements?
Yeah.
Especially things people would notice right away, like how clear their call sounded, and maybe more importantly, privacy.
Yeah, privacy was a massive gain, absolutely. Because the signal was now digital, just ones and zeros, it became possible to easily and crucially effectively encrypt the calls.
Encryption built in.
Pretty much. Your sources point out that the kind of casual eavesdropping that was, a genuine problem with simple radio scanners on 1G networks, that was virtually eliminated. Gone.
Wow.
So this was really the first time that mobile phone conversations had a truly meaningful level of privacy. People could talk without worrying quite so much about who might be listening in.
That's a huge deal.
It really was. And then on the call quality front, converting the voice to data allowed the networks to use something called error correction codes.
Okay, what did those do?
Well, essentially, these digital codes could identify and even fix errors or filter out the static and interference that were just so common on those 1G analog calls. The crackles, the hiss.
Yeah, definitely remember those.
Error correction helped get rid of a lot of that. The result was significantly clearer, much more reliable voice connections. Calls just sounded better, plain and simple.
So, better privacy, clearer calls. Sounds like a win-win already. But you also mentioned efficiency. How did going digital impact the network's ability to handle more users, getting more people on at once? And critically, what else did it open the door to, beyond just making voice calls better?
Efficiency was another huge win, definitely. Digital compression techniques, these clever algorithms, basically meant you could squeeze more voice data into the same amount of radio spectrum. Think of it like packing your suitcase more efficiently.
Okay, fitting more in.
Exactly. Plus, new ways of managing how multiple phones actually shared the network channels, these access methods we'll probably talk about, allowed for much greater capacity overall.
So what did that mean for the user?
Well, it meant that in busy areas, like city centers, more people could actually make calls simultaneously. It's significantly reduced those frustrating all circuits are busy messages that really plagued 1G networks. You could actually get a line out more often.
Right. Fewer dropped calls or failed calls. Makes sense.
Yeah. But the truly groundbreaking part, the thing that set the stage for everything else, was that because the network was now designed to handle everything as data, including voice, which was now just another form of data, it meant the network could now transmit other types of data too, not just digitized voice.
So that's the key. Turning voice into data meant the pipes could carry any data.
Precisely. This fundamental shift made the network a kind of universal pipe for digital information, not just a system for speech. And that was the essential gateway. It's what enabled all the data services like texting, early web browsing that would come to define the 2G era, and frankly, pave the way for everything that followed.
That makes perfect sense. Turning voice into data wasn't just about voice. It was about opening the network up. Okay, so your sources talk about two major kind of competing standards that emerged in this 2G world. Let's dive into the first one. What was GSM and what was the core technology it actually used?
Okay, yeah. The first major standard, and the one that became dominant globally, was GSM, the Global System for Mobile Communications. This was primarily a European development initially, but it spread worldwide pretty quickly.
Right, GSM. I remember that name everywhere.
Exactly. And the technology GSM used for handling multiple users on the same frequency was called Time Division Multiple Access, or TDMA.
TDMA. Okay, how did that work?
Well, the way the material explains TDMA is pretty straightforward. It basically divided each frequency channel into specific, distinct time slots, typically 8 of them per channel.
Like little slices of time.
Kind of, yeah. So instead of everyone sharing the frequency continuously, multiple users would essentially take rapid turns transmitting. Each user's phone would send its little burst of digital data only during its allocated time slot. Then the network and the receiving phone would piece all these bursts back together at the other end to reconstruct the conversation or data stream.
Okay, so rapid turn taking within the same frequency. Got it. And GSM introduced something else, something really fundamental that we still rely on heavily today, right? Something that changed how we thought about owning a phone versus owning a service.
Absolutely, you're spot on. The material highlights this very clearly. GSM's most lasting, and you could argue its most revolutionary innovation, was the SIM card, the subscriber identity module.
The SIM card, of course.
That small little removable chip. It seems so simple now, but it was truly revolutionary back then because it completely separated your identity, your phone number, your account details, all that stuff from the physical phone, the handset itself.
Right, before that, the phone was your number, essentially.
Pretty much, yeah. Your identity was often hardwired or programmed directly into the phone by the carrier. The SIM card, though, it gave consumers this unprecedented freedom. You could easily switch phones just by popping that little chip out of one device and sticking it into another compatible one. Your number and service went with the chip, not the phone.
That's huge for upgrades or if you broke your phone.
Exactly. It was a massive change in user experience, and it gave people flexibility they'd never had before. And its impact is so profound, as your sources note, that the whole SIM concept is still dominant globally, even now in the era of 5G decades later, still sticking SIM cards in phones.
That simple little chip really did change everything about phone ownership. Incredible. Okay, so GSM had TDMA for access and the game-changing SIM card. What was the other major 2G standard, CDMA? And how did its technical approach differ from GSM's TDMA?
Right. The main competitor, particularly strong in North America and parts of Asia, was CDMA Code Division Multiple Access. And CDMA took a fundamentally different approach to managing multiple users on the same frequency band.
Okay. Different how?
Well, instead of dividing the frequency band into time slicks like TDMA did with CDMA, users essentially shared the same entire frequency band simultaneously. Everyone could transmit at the same time over the same frequencies.
Wait, how did that work? Wouldn't it just be noise?
That's the clever part. To separate everyone's communication, each user's data was assigned a unique digital code, almost like a secret signature or language. This code was stamped onto their data before transmission.
Okay.
The receiving phone, knowing the specific code for the message it was supposed to receive, could then use complex mathematical algorithms to kind of unscramble or isolate just that one conversation or data stream from all the other signals sharing the same frequency at the same time. It filters out everything that doesn't have the right code.
Huh. So everyone's talking at once, but in different languages or codes, and your phone only listens for the code it understands.
That's a pretty good way to think about it, yeah. It was a more complex code-based approach compared to TDMA's more straightforward time-slicing method. Both aim to increase capacity, just using very different techniques.
Very different indeed. And how did CDMA handle the user identity part, since you said GSM's big thing was the SIM card? And how did these two standards, GSM and CDMA, end up spreading around the world? Was it an even split?
Right, that's another key difference, especially in the early days. With most early CDMA networks, because there wasn't typically a removable SIM card like in GSM, the user's identity, their phone number, service plan was often tied directly to the specific phone handset itself.
So like 1G in that respect.
A bit more like 1G, yes. Switching phones usually involved a more involved process. You'd have to contact the carrier to activate the new device and provision it on their network. It made swapping phones definitely more cumbersome, less flexible than with GSM, where you just move the SIM.
Okay, less convenient for the user there. And the global adoption.
In terms of adoption patterns, GSM, partly because it originated in Europe with strong standardization efforts and partly because of the SIM card's flexibility, really became the dominant mobile standard across most of the world. Europe, Africa, large parts of Asia, Australia, mostly GSM.
So GSM took the lion's share.
It did. CDMA, while technologically sophisticated, was primarily adopted in North America, think carriers like Verizon and Sprint in the US, or Bell and Telus historically in Canada, and also had significant presence in parts of Asia, like South Korea and some countries in the Americas.
Okay, so a geographical split, roughly.
Yeah, and the standards divide, this GSM versus CDMA split, it had real consequences. For quite a while, it meant that phones weren't universally compatible. A GSM phone simply wouldn't work on a CDMA network and vice versa. This created significant fragmentation and real interoperability challenges, especially for international travelers back then. You often needed different phones for different regions.
Oh, yeah. I remember needing specific world phones or renting phones when traveling. That explains why. Okay, let's shift gears a bit. We've talked about the underlying tech. Let's talk about the user experience, the actual devices that people were using, and the services that this new digital capability enabled.
Absolutely. And this is where you see the impact ripple out. One major effect of 2G's digital efficiency, the compression and access methods we talked about, was the democratization of mobile phones.
Democratization. How so?
Well, compared to those bulky, often briefcase size and very expensive 1G phones.
The bricks.
Exactly, the bricks. 2G technology allowed for much, much smaller, significantly cheaper handsets, and just as importantly, dramatically better battery life.
Ah, battery life. That's a big one.
Huge. This combination, smaller size, lower cost, and batteries that could last for days, not hours. This combination is what transformed the mobile phone from, an expensive gadget for business elites or the wealthy into a true mass market consumer product. Suddenly, lots of people could afford and practically use a mobile phone.
And this is where those iconic phones we all remember come into the picture, right? The ones that seem to be everywhere.
Precisely. This technical shift to 2G directly enabled the rise of those legendary devices. We're talking about phones like the famously indestructible Nokia 3310.
Ah, the 3310, the meme phone.
The very same. Or things like the super slim Motorola RAZR later in the 2G era, or those early, very popular Samsung flip phones. They're smaller size, they're much lower cost compared to 1G, and that incredible battery life, seriously, often lasting several days, sometimes even a week on a single charge, something we can only dream of today.
Tell me about it.
That's what made them ubiquitous. They became symbols of the era, almost cultural artifacts. They weren't just phones. They represented this new mobile freedom for the masses, enabling that mass adoption we talked about. And these phones, they were the gateway to the new digital services 2G offered most notably.
Texting.
Yeah.
Gotta be texting. What was the story there? It seems so basic now, just characters on a screen, but it feels like it changed absolutely everything.
It truly, truly did. You could argue, and the source material strongly suggests this, that 2G's single most significant cultural contribution was the introduction and explosion of the short message service, SMS. Those simple 160-character text messages.
160 characters. Seems so limiting now.
It does, but back then, well, the material notes, it initially started almost as an afterthought. A simple way for the networks themselves to send alerts to phones, like, you have voicemail.
Okay, a utility feature.
Exactly. But users, especially younger users, latched onto it and it just exploded in popularity. It created a completely new communication paradigm. Think about it. It was brief, it was asynchronous, meaning you could send it now and they could read it later, unlike a phone call.
Right. No need for both people to be available at the same time.
Precisely. It was discreet. You could text under the table in a meeting or class. Maybe you shouldn't have, but you could. And it was fast, or felt fast, compared to email back then. It quickly developed its own unique language, too, didn't it? All those abbreviations, the emoticons.
LOL, BRB, yeah. A whole new dialect.
Absolutely. So SMS didn't just add a feature to phones. The sources are clear. It fundamentally changed how people interacted, how they made plans, how they expressed themselves, all in these short, quick bursts throughout the day. It rewired social interaction for millions.
It's actually amazing how a technical limitation, that 160-character limit, ended up fostering this whole new form of creativity in language.
Wild.
Okay, so SMS was huge. Beyond basic text, how did 2G start to handle maybe richer content, pictures, sounds?
Yeah, as the 2G networks evolved a little, sort of matured, we saw the introduction of MMS, the multimedia messaging service.
MMS, right, picture messages.
Exactly. You can think of it as the next step, the evolution of SMS. MMS allowed users to go beyond just plain text and send messages that included, well, pretty low-resolution photos by today's standards.
Very low res.
Oh, yeah, grainy stuff. But also simple audio clips, little voice notes, and even very short, choppy video files sometimes. While it was incredibly basic compared to the rich media we share effortlessly today on social media, MMS was that very first step. It was the first taste people got of sharing multimedia content from their phones.
The beginning of sending selfies, maybe.
Probably the very, very beginning, yes.
Ooh.
A crucial first step towards rich mobile media sharing.
Okay, so we had better voice, we had the explosion of SMS, we had early picture messaging with MMS. But you mentioned earlier that the real promise of digital was that data gateway.
Right.
True mobile internet access. It started slow, right? Can you explain GPRS, which people often call 2.5G, and what that actually introduced?
Yes, GPRS, General Packet Radio Service. This was a really critical upgrade, and that 2.5G label makes a lot of sense because it was a significant step up in data capability, even though it definitely wasn't full 3G yet.
So what was the big change with GPRS?
The key thing GPRS introduced was packet switch data to mobile networks. Now, that sounds technical, but it had two really major implications for users.
Okay, break it down.
First, the connection could be effectively always on. Before GPRS, using data on your phone often felt more like dial-up internet on a computer.
Oh.
You had to explicitly initiate a connection, wait for it to connect, use it, then disconnect.
Right, like making a data call.
Exactly. With GPRS, your phone was essentially connected to the data network whenever a signal was available in the background. No more dialing up for data. That was a big shift in usability.
Always on. Okay, what was the second implication?
The second one was how you were billed. And this was a big shift for carriers and users. You started being charged based on the volume of data you used, kilobytes or megabytes, rather than the duration you were connected, which was how voice calls, and those earlier data calls were billed. Paper megabyte was born here.
The beginning of data caps and plans.
Pretty much, yeah. It changed the economics of mobile data. Now, let's be really honest here. The speeds were, well, incredibly slow by today's standards. The sources mention averages around maybe 30 to 40 kilobits per second.
30 to 40 kilobits. Wow. That's
painful.
Yeah.
Yes, it sounds excruciating now. But despite that crawl, despite the slowness, GPRS enabled things that were impossible before. It allowed for the very first mobile web browsing, usually on very basic text-heavy WAP sites.
WAP, Wireless Application Protocol, I remember that. Very stripped-down websites.
Very stripped down, exactly. It also enabled early forms of mobile email access, maybe just fetching headers or short messages, and the first mobile instant messaging applications. It was slow, it was clunky, but it was the foundation. It was the first real taste of the internet in your pocket.
30, 40 kilobps.
Yeah.
Yeah, painful is the word.
Yeah.
Okay, so GPRS was the first step, 2.5G.
Yeah.
How was this very early, very slow mobile data experience improved upon before we made the full jump to the next generation, to 3G?
Well, to try and make that early data experience a bit less frustrating, networks introduced an upgrade called EDGE. That stands for Enhanced Data Rates for GSM Evolution.
AGE. Okay, another acronym.
Another one. And following the pattern, this is often referred to as 2.75G because, again, it wasn't a full generation leap, but it was a noticeable improvement built right on top of the existing GPRS infrastructure. It was an enhancement, an evolution.
So what did ADG actually do? Faster speeds?
Primarily, yes. EDGE offered a significant speed boost compared to GPRS. Theoretically, it could reach speeds up to maybe 236 kilobits per second.
Okay, still not fast by today's standards, but definitely better than 40 kilobps.
Oh, much better. Several times faster, in fact. While still obviously very slow compared to even basic 3G, let alone 4G or 5G, this boost made those early mobile internet experiences, browsing WT sites, checking email, maybe basic mapping, slightly more usable, slightly more tolerable.
Less waiting, basically.
Less waiting, exactly. And crucially, EDGE served as a really important bridge technology. It improved data performance just enough to keep things moving forward, to keep building user expectations and appetite for mobile data right before the much faster, true mobile broadband speeds of 3G started to arrive. It filled a gap.
Okay, so a series of steps. 2G digital voice, then SMS MMS, then slow GPRS data, then slightly less slow DE data, all paving the way. Looking back now at this whole 2G generation, from the early digital switch to ADGE, beyond just fixing 1G's problems, what do you say its overall lasting legacy and impact is on the mobile world we know today? What's the big picture?
Yeah, pulling back to the big picture, your source material synthesizes the major impacts really well, I think. There are maybe 4 key legacy points that stand out.
Okay, let's hear them.
First, as we touched on quite a bit, it truly democratized mobile phones. The underlying digital technology allowed for those smaller, much cheaper phones with way better battery life. And that combination is what transformed the mobile phone from an expensive gadget for the elite few into a genuine mass-market consumer product, accessible to hundreds of millions, eventually billions, globally.
Making it mainstream. Got it. What's number 2?
Second, it laid the essential foundation for mobile data. Even with those painfully slow GPRS and EDGE speeds, 2G was what first ignited the public's real appetite, the desire to have internet access in their pocket wherever they went. It built the initial commercial models, the technical infrastructure, however basic, that all future faster mobile data networks would build upon. It got the ball rolling.
Planted the seed for mobile internet.
Okay.
Third,
and this is maybe underestimated sometimes, SMS created a whole new communication culture. Texting wasn't just another feature added to a phone, it genuinely changed society. It created new, immediate, discrete ways for people to interact, to organize, to express themselves. That impact on social dynamics is profound and lasting.
Yeah, the cultural impact of texting is huge. And on the last point.
And finally, a more technical point, but still crucial, the GSM pioneered SIM card. That simple chip became the de facto global standard for user identity on mobile networks. It's a system so effective, so user-friendly in its basic concept that it remains dominant even today as we use advanced 5G networks. That standardization was key.
That list democratization, data foundation communication culture, SIM standard really drives home just how fundamental 2G was. It wasn't just one thing, it changed the device, the network, and how we used it all.
Okay, to wrap things up, your sources mentioned thinking about the 2G era specifically from our modern perspective here on, let's say, June 10th, 2025. What's the final takeaway? How should we view 2G from where we stand today with hyperfast connectivity? It's a great question to end on. From our current vantage point, where we casually stream 4K video on our phones thanks to multi-gigabit 5G networks, those initial 2G data speeds, 30, 40, maybe 200 kilobits per second with EDGE, they seem almost impossibly comically slow, like comparing a horse-drawn cart to a spaceship.
Right. It's hard to even imagine browsing like that now.
It really is. But the material makes it absolutely clear. Despite the speed limitations, 2G was a truly pivotal turning point in technological history. Yes, it fixed 1G's big problem, security, call clarity, by making that crucial leap to digital. That was essential.
But the real story is.
But its true, profound, long-term legacy lies in what it added beyond just better voice calls. It lies in the transformative power of SMS, which genuinely reshaped social communication globally. And it lies in those first, hesitant, often frustratingly slow steps into the world of mobile data with GPRS and EDGE, delivered, remember, often on those incredibly durable, widely accessible mass-market phones.
So it wasn't the speed, it was the possibility it introduced.
Exactly. It was that first taste, however limited, of having the internet, having digital communication beyond voice in your pocket. That's what created the fundamental user demand, the insatiable appetite for the faster, richer, always connected mobile experiences that every single subsequent generation, 3G, 4G, 5G, has raced to deliver.
That's fascinating. So the desire for internet in your pocket wasn't really born with the iPhone or the first Android phones, was it? It started way back in the era of like Nokia candy bars and flip phones with tiny monochrome screens, all thanks to 2G, showing us, however slowly, what might be possible.
You've nailed it. Your material concludes really powerfully, basically saying that 2G truly built the essential digital framework, the standards, the infrastructure concepts, the user habits, the market demand upon which the entire smartphone revolution would eventually inevitably stand. Without that foundational digital leap by 2G, without SMS creating that new communication habit, and without GPRS and EDGE giving us that very first tantalizing glimpse of mobile data, the mobile world we live in today simply wouldn't exist as we know it.
That's a truly insightful thought to end on. It really puts into perspective how those early, seemingly primitive steps were actually the most critical ones in the long run. It wasn't about being perfect, it was about starting something new.
Indeed. Innovation doesn't always arrive fully formed or at breakneck speed. Sometimes that initial spark, even when it's small and maybe flickers a bit, is the thing that defines the entire future trajectory. 2G was definitely one of those sparks.
Well, that was quite the deep dive into the genuinely revolutionary world of 2G mobile networks. We really hope this conversation, drawing on the material you provided, has helped you pull out the key insights and maybe gain a deeper appreciation for just how transformative this often overlooked era truly was.
Yeah, thank you for sharing these sources with us and for joining us on this exploration back in time, technologically speaking. It's been fascinating to revisit.
And if you found this deep dive valuable, if you enjoy exploring the tech that shapes our world and understanding its roots, please be sure to subscribe to Tech, AI, and Beyond, wherever you get your deep dives and podcasts. We'll keep unpacking complex topics and bringing you the most important nuggets of knowledge. Thanks for listening.